Hello friends, today we are going to do the kinetics, that is effect of time on the removal of dye or the pollutant using adsorption. Okay, so you can see we have here the methylene blue dye, okay, and the concentration is around 10 ppm. Okay, so the pH here is fixed, the pollutant concentration is fixed, and also will fix the adsorbent amount or dosage. Going to transfer equivalent amount of the adsorbent in all the vial here. Okay, so this is around 15 milligram, and the adsorbent here is the raw pozzolana, raw volcanic ash. So we have made around, so 1 2 3 4 5 6 7 8 9 10, so 10 vials, and this one will be for the control. Now we will transfer around 30 ml in all the vials. Okay, so let us transfer. We have transferred all the vials, okay, into the Orbi shaker. Now we will, and this is our respective time, 0 5 15, so we'll go up to 6 hours. Now let us first of all set the time. This is set around 6 hours. Then RPM we will set. Okay, now we'll start shaking. So after 5 minutes we will measure the concentration after centrifugation. Okay, after 5 minutes the concentration is around 7.018. So 15 minutes the concentration is 5.953. Minute the concentration is 4.1. 60 it is 2. It is 1.7. 80 it is 0.9. So now guys, we will plot the kinetics data. Okay, before that we can jot down some, or you can say we can discuss some important points. So the key factors that control the adsorption process is the duration of contact between the adsorbent and adsorbate. So adsorbent here was raw pozzolana, or you can say volcanic ash, and the pollutant was methylene blue. And for a specific initial dosage, so dosage here was around 15 milligram, and it provides details on the adsorption kinetics of the adsorbate. And the adsorption kinetics also provides us the valuable info on the possible adsorption mechanism and their potential rate limiting step during the adsorption process. Or adsorption kinetics also describes the proportion at which the solute is adsorbed and the resident time of the adsorbent on the solid liquid interface. Okay, the removal efficiency of any pollutant and adsorption capacity will increase with the amount of time, and and the efficiency and adsorption capacity will however diminish after it had reached at a point that is the equilibrium time. And the kinetic data were fitted to the, so we applied to the linear models. We can also apply to the non-linear models also, pseudo first or second order, and there are other models also like Avrami, interparticle diffusion. I have already uploaded many videos related to the non-linear fitting onto the different adsorption kinetic models. So here Q2 and QE are the adsorption capacity at time t and equilibrium condition, and these are K1 and K2 are the constant, or you can say factors. So in our case, the methylene blue removal was faster during the initial stage, okay, until 240 minutes. If you look at to the data, so gradually it was faster, okay, during, you can say, 180, and then it decreased, okay. Now the after optimum time there was no substantial change, and the increasing adsorption capacity was faster at the start of adsorption process, and it decreased gradually, okay, after attaining a constant value. And the the preliminary adsorption could be accredited to the abundant adsorption site onto the adsorbent, and which is to be occupied by the methylene blue molecules over time. Now this is our fitting. We can see the fitting. So here, after applying into the linear models, so in first order it is 0.93 the fitters, and this is my slope, and this is K1, sorry, constant, and this is the adsorption capacity, okay. And for our data is fitting to the pseudo second order, so you can see here the adsorption capacity is 40, which is almost analogous to the QE experimental. This is from the model, and this is our K2, and this is our R square, okay. And after copying these values, you can see here, so the initial concentration was 10, and this is our experimental value, and this is our model. So this is conforming to the second order, which implies that the chemisorption as the rate limiting mechanism of the process, okay. And also you can plot the data using the origin. You can just copy these and then you can plot. You can also watch on my channel how do we plot how do we fit the adsorption data, kinetics data to the linear and non-linear models, okay. So this was all about the effect of kinetics, or you can say effect of time, okay, on the absorption of the methylene blue by the raw pozzolana.